Hello everyone, True Zero Emissions here. Okay, so I'm making this video, I'm recording it and I'll upload it because my last video on my wimshurst machine, my larger wimshurst machine, this is a small wimshurst machine. If you look up sparkit, that's S-P-A-R-K-I-T. If you look that up on Google, you'll find these kits. I don't think they cost that much. I forgot the exact price. I paid to have it assembled for me. You can pay an extra few dollars to have it assembled. I think it's approximately, at the time, many months ago, it was approximately $15 to have it assembled. I think the unit was around $25 or maybe $35 approximately, but I think it was under 50 or 60 with everything, with shipping and everything. It was around 60, I think, with shipping, having it assembled. I might have bought extra parts, like see this? This is, you put this on top of, so you put this, let's see how you do this. I'll show you right now how this works. That goes there. This goes here. And this goes here. And then when you turn it on, isn't that interesting? And now I'll take it off. I don't want to touch that because it has a lot of power. Oh, I'm going to touch it now. Okay. I don't want to touch both sides, I think. I don't want to complete the circuit, right? The capacitors in there, I think there's capacitors in there, if I understand correctly, are holding a charge. This is counter rotation. First, I want to apologize for my last video not coming out well at all. It was a live stream, and I don't understand why it didn't come out very good. I'll show you briefly the wimshurst machine that we made a video of, that I made a video of, we being True Zero Emissions and I. This is the wimshurst machine I made a video of, and I was explaining all these things about thoughts on variations of a wimshurst machine, right? A wimshurst machine that can, how can it be changed? First of all, how does it work? Why do we have counter rotation? Why do we have the areas? Why does it work even when these brushes aren't touching completely, right? See how they're not, watch this, see this? They're not totally touching, and yet it still works. Now in my last live stream, I was showing all this, but I realized later when I watched it, the beginning is clear, and then after a few minutes into the video, the quality went down significantly, and I'm really surprised by that. That doesn't usually happen. I was making the video on Wi-Fi, so I had really good connection. Full Wi-Fi strength, full bars, so it doesn't make sense to me why that happened. But you can listen to the sound in that video, and then the ideas are still relevant. And then I'm going to make another video right now. Right now we're going to make a video with this about the smaller wimshurst machine, okay? So it's the same thing, but it's just smaller. And I want to talk about thought experiments, right? So this is a great toy, I think, for children to learn with. They have to be careful to not get shocked. So there's probably an age limit, because at a certain age, I mean, even kids that are old enough to play with this might still want to touch it and read up on how dangerous that is. Because it hurts. I don't recommend getting shocked by it. So anyway, let's discuss what's happening here. So I didn't build this myself. I bought this pre-built. It has 2 electric motors. These motors are spinning these discs in counter rotation. Now listen to this. This is very interesting. my understanding is we want these discs to be very close together. Now, why does that affect our power output, right? Why does how close these discs are together affect the power output? What's happening here? What is happening here? So we have these intermittent, I'm calling it intermittent, metal pieces here, right? These are intermittent, right? There. It's not continuous, right? And on the other side, we have the same thing, right? There. They spin in opposite directions, and the two discs, my recollection of what we want here is for these to be as close together as possible without touching one another. And that's what I did. Because you can slide these discs on the motor shaft, you can slide them. So when I received this in shipping, I had to adjust that space. It's powered by 2 AA batteries. Now look at here. You see these little, I don't know if we call these collectors. For the moment, I'll call them collectors. They're not touching the metal, right? But they're placed exactly in the same place on opposite sides of the disc. And the other side has them too. See that? In the same place. So those are here, right? And then over here. On both sides. What else do we have? We have these brushes, and these are used in, I was told these are used like in electronics for grounding static, what are they called? Static discharge brushes? I think they're called something close to that name. And I don't know what the material is, what they're made of, but it's like a soft material, it's not metal. And I really like that because my large wimshurst machine has metal, which scratches this metal, right? I don't want metal scratching metal. So let's see what's touching here. Let's examine this and see what's touching. This one's touching. There's one on the opposite side touching, right? That one's touching. So we have one here, and then in the bottom, we have one here. See it in there? And we have one on the opposite area over here. If you see that in there, see that brush? There it is. Okay, everyone, we'll make more videos. I'll continue to make more videos sharing my thought experiments about what can be done with this. But for the moment, actually, one of the things I wanted to share with you, I want to reiterate some of my thoughts that I had in the previous wimshurst machine video, which wasn't coming out very well. The live stream the quality's not coming out well. So I don't know if that's still, it says it's done loading, it's done. So I don't know why that happened, why the quality's so low. But I will always make many videos of anything I talk about, because each time I talk about something, it's more clear to me. I have new ideas, new perspectives, new ways of seeing it. And that's why I just love to talk about things over and over and over. So this channel is really me repeating myself like thousands and thousands of times, but moving through different levels of thought experiment possibilities, if I say it that way. So okay, so when I'm looking at this, here's some thoughts that I've had. Now at the moment I'm going to reference the other wimshurst machine. Well, no, I guess I can talk about this one. I'm still thinking about the other one because I spoke so much about it. One of my thoughts were, what if we have, this is additionally, in addition to what I've said in the last wimshurst machine video, imagine these intermittent conductors, I'm calling them. Intermittent conductors, I'm calling these, right? Imagine these being magnets. And instead of having them have so many of them, right? Because when does the battery charge? When does the battery receive its charge? Does the battery receive its charge when the magnet is at the coil? When the magnet goes to the coil, right? Because we're talking about magnetism and coils, right? When the magnet goes past the coil of wire, with or without an iron core, a ferrous iron core, meaning magnetic iron core, able to attract a magnet. When the magnet passes that coil, is that when it charges the battery? When it goes to the coil, right? Or is it when the magnetic field leaves the coil and then the energy collapses from the environment into the coil, right? Is that what's happening? Because if that's the case, then to me, it's logical, if we use that word, that I would want a large space between the magnets. A very large space. Because the battery's charging between the magnets, not where the magnets are. So if we have continuous magnets, when does the battery charge? When does it ever have a chance to charge if we just have continuous magnetic fields? And if you have all north poles, for example, all north poles of magnets facing the coils, and we have spaces, what's the difference between having all north poles? Right, let's say we have 6 magnets, right? We have 6 magnets on a wheel. So if we had 6 magnets on here, right? So 1, 2, 3, 4, 5, 6. And then we had 6 coils, let's say. And all those magnets passed all the coils at the same time. And then there was a break of equal time between each set of magnets, right? So all the magnets and all the coils pass each other at the same time, and then they're free. And then they pass each other again, and they're free. In the free time, the break, the break from the magnetic field, if that's when the energy collapses into the coils that we use to charge batteries, for example, right? Then to me it makes sense that we want the coils to have a break. A good break, a nice one. In fact, we could even try having one real powerful magnet, just one real powerful magnet, and then many coils, right? Or just one magnet and one coil. Just try that too, and then that wheel passes that coil. And then that pulse. And what's the pulse I'm talking about? Am I talking about the pulse of the magnet going in contact with the ferrous iron core or the copper coil, or both? Or am I talking about the pulse that happens when that magnetic field leaves I'll say the coil, right? Because in a way we're charging that coil that coil, when the magnet passes the ferrous iron core or the copper coil with a load on it, with a load on the copper, right? There has to be a load on the copper. The copper has to be connected to something. So in this instance, we'll talk about the copper being connected, the 2 ends of the wire of the copper coil being connected to a full wave bridge rectifier, which cost a couple dollars, right? They're usually a couple dollars on Amazon or anywhere on Google. And then going into the battery from there, right? Because then we have our plus and minus, right? Out of the full wave bridge rectifier. So is that impulse? Is that an impulse? When the magnetic field leaves the coil, does the environment collapse its energy in on the coil and send that strong pulse to the battery? And then what does the battery do? Right, so if we talk about Dirac holes, right, Dirac, D-I-R-A-C, if the electrons are being shaken loose from the Dirac holes, the environment, right, do they go directly from the environment and directly to the battery? Right, so are we ringing the battery like a bell when the environment collapses in on the coil, this environment right here that my hand is moving through, this space, and that my hand exists within? When that pulse goes or that impulse goes to It's often called an impulse. When that goes to the battery, does that ring like a bell and shake the electrons loose from the Dirac holes? This is theory, right? We're talking about theory right now. Some people say, I don't care about the theory, I just want it to work. Okay, you could do that too. You could just, experiment and just see what things do. And hopefully share your experience so I can study what you're doing and see what your results are. Because I love to learn what people are doing and what's happening. And talk about what you think is happening as well. I love that. Thank you all for doing that, all of you. So for shaking the electrons loose from the Dirac holes directly into the battery, if that's happening, it makes sense that we can't measure that impulse. Measuring it with an amp meter is not going to do anything. We can measure it with a voltmeter, though. We can measure our battery voltage and watch it go up. But is an amp meter going to help us in an instance where we're getting an impulse going to the battery? I don't think it would work, right? This measures constant current, doesn't it? Does that measure impulses? I don't think it does. Not that I'm aware of. That's an amp meter. Well, it's constant current, right? That's my thoughts. That's my understanding. Please make videos to clarify your perception of what you see happening. But don't forget, consideration of what the great masters of energy have theorized and done experimentally is important to study as well. And that's what I consider, I don't remember Tom Bearden and John Benini or any of the great masters of energy saying you can't do something. In fact, John Benini said, if you watch Energy from the Vacuum, he says in that series, anything you can imagine, you can do if you set your mind to it. How many of you have heard that before? It's a very popular idea. Anything you can imagine can be, right? And that's why I add to that, oftentimes I add, so long as it causes no harm. Because we don't want to hurt each other. We want our needs met, but we don't want to hurt each other, because hurting each other doesn't get anyone closer to their needs being met. Or if a lot of people have to be harmed for other people to have their needs met, what good is that, really? What good is that? That's not the goal of anyone. Everyone wants everyone to have their needs met. It's so long as they're not caused harm, right? No one wants harm caused to them. So utilizing systems of war is not logical. It's not logical at all. It's actually could be perceived as being very immature. And that's what a lot of people call it. They call war immature. Because it's not, and I'm not talking about the people that go out there fighting. I'm talking about the people that any use of war as an alternative to solution-oriented world collaboration, what I call it. We have to consider everyone, right? We have to consider everyone. Okay, everyone, I have to go at the moment, but I'll be back to make more videos. And think about how many different ways we can make the wimshurst machine work, and how can we integrate John Bedini and Tom Bearden, theory and experiments. Theory and experiments. Right? John Bedini's inventions. How can we bring the wimshurst machine design and John Bedini's system? So how can we bring counter rotation to John Bedini's designs? That's one thought. Okay, everyone. Looking forward to watching your videos and reading your comments, but mostly watching your videos, because a lot of people have comments turned off. Watching your videos on your thoughts, your thought experiments. Have a great day. Bye.